Hello and welcome to our SOL review of A.02a exponents. So what we have here is just a bunch of different little problems set up, and we're going to go through all of them because some of them could be a little confusing. Let's just start off with regular old x to the fourth power here. Now what I want to do is write this in expanded form to remind you that the operation associated with exponents is multiplication. So you really should think of it almost as an exponent as multiplication. Go ahead and write that in there. In fact, it's also sometimes referred to as repeated multiplication because if you see, we're repeating multiplication each time. Now the exponent tells us how many bases we have. So this is the base, here's the exponent, and since it's a 4, 1, 2, 3, I have 4 bases all being multiplied together. This is the expanded form, but the real way to clean this up is you would actually write it as this. But it's good to know the expanded form because sometimes it's helpful to write it out. Case in point, the second problem here I have set up, we have x squared times x cubed. Well, x squared is x times x. I'm going to put a big dot to represent the dot that's right there. And then x cubed would be x times x times x. Well, just count how many bases you have. 1, 2, 3, 4, 5. And since it's all multiplication, that would be x to the fifth. Now, you would think it'd be pretty similar to when you do it with a parenthesis, but there's a slight tweak to it. So on the inside of the parentheses, going back to the last lesson, we're going to go ahead and clean that up. And what I'm going to do is just write it a little bit differently. So you see that we have x squared. That means on the inside of these parentheses, we have x times x. Okay, but we have to repeat this 3 times. So we have to do 2 times for the base on the inside, which we've done, but now we're going to do x times x 3 times. So 1 set already done, 2 sets done, 3 sets. And that actually gives us 1, 2, 3, 4, 5, 6. So even though I use the same exponents in just using those parentheses, it kind of tweaks what happens. Some people like to use the shortcut of whenever it's just written like this, you add the exponents, and whenever they're by parentheses, you multiply them. That can get a little dangerous, so when in doubt, just write it out. Now here we go. We have a division bar, which does tweak the problems a little bit. So a squared would be a times a on top, and the bottom we'd have a times a times a for a cubed. Now what happens is when you have a value on top and a value on the bottom of a monomial like this, you can actually cancel them out as long as they're the same and there's no addition or subtraction signs. So we can cancel that a out, we can cancel that a out, and they both go away, and we're actually left with, on the bottom, an a value. Now, what we put on top is not 0. As you have to remember, with multiplication and division, when things cancel out, we're left with a 1. So this problem would be 1 over a. And that makes sense because when you think about it, we had more a's on the bottom in the denominator than we did in the numerator. Now, here's a fun little trick to remember because the SOL people love throwing this problem in there. Anything to the power of 0 is 1. And they love to sneak it in here. I'm going to do a little bit of an extra example. So if you see something like 2xy squared to the power of 0, all of this, because you need to repeat it 0 times. That even sounds weird as I say it, but this would also be 1. Cool little trick. Now, there's also these pesky negative exponents we need to talk about. A negative exponent is actually a fraction. So instead of c to the negative third, this would become 1 over c to the third. The reason is because earlier I mentioned that exponents are considered repeated multiplication. However, when you get into the negative realm, the opposite of multiplication, which is what happens when you have a positive, is division. So the negative exponent is associated with division. There's a cool little trick that can help you too with this stuff as well. For instance, if you notice here, I have a negative exponent in the denominator. Now, as I just said, anytime you have a negative exponent, it flips it into a fraction. But if it's already on the bottom, then what happens is, to get rid of the negative exponent, it moves to the top. And just mentioned, as we did in the problem over here, you can't just have an empty denominator. It's not 0 because we're only working with multiplication and division, so it's 1. And as we all know, dividing by 1 doesn't really do anything. So our answer for this problem is going to be a squared b cubed. Same thing over here. We already actually have a fraction set up, and we have this negative exponent we need to deal with. So what we're going to do is move it to the bottom. So this will become a to the 5th b squared. And again, on top would be a 1. Now, you're not technically wrong if you wrote this as 1 over b squared times a to the 5th. However, in the math community, it's kind of more proper to start with the variable first. That kind of is in order. So if you notice, it goes a, b in this problem. And as we look at the next example from the SOL, you'll see it also goes in alphabetical order. Speaking of the SOL, here is an SOL question. So, which of the following is equivalent to, looks like a to the 12th b squared over a cubed b to the 6th. Okay, so this is similar to that division problem. I could write this out 12 times, but I think that's going to be a little bit much. However, we know that we have 12 a's up top and 3 on the bottom. That means we can take away 3 a's from both. So when I start cleaning this up a little bit, a to the 12th take away 3 would be a to the 9th. And on the bottom, we'd have a to the 3rd take away 3. That would just be, well, 0. And anything to the power of 0, as we've talked about, is 1. I'm going to draw a fraction bar. We have b squared on top, and we have b to the 6th. Well, since there's more b's on the bottom, b is going to stay on the bottom. And if we look, we're going to take away 2 from both. 2 minus 2 is 0, so this b essentially cancels out like that a did. And 6 minus 2 is 4. So our answer is a to the 9th, b to the 4th, which, when I look at my answer key, would be a. Thanks for watching.